Let's write the balanced equation for the reaction between copper and sulfur. And we're told that there are two possible reactions. The reason there are two possible reactions is because copper commonly forms two different cations. It's a transition metal, and many transition metals form multiple cation charges. Let's consider the first scenario. We have copper solid, and that's going to react with sulfur, and that's going to form a compound of copper and sulfur. And even though the electronegativity difference here is not greater than 2, on your test, if you see a metal and a non-metal compound, you can assume that it's a solid if it's at room temperature. So let's consider that this is a copper cation with a 2 positive charge. Sulfur forms 2 negative sulfide anions. You can crisscross these numbers to get the ratios of those ions. In order to make this a neutral compound, it has to be a 1-to-1 ratio. So in this first scenario, the equation is already balanced. This compound is called copper 2 sulfide. And if you're using the older naming convention, use the Latin root with an IC ending for the higher charge on the cation, although this is not very common these days. It would be called cupric sulfide. Now let's consider the second scenario. We have copper reacting with sulfur, and that's going to form a compound of copper and sulfur. Now the reason I know this is when you see two elements on the reactant side before the arrow, the only thing for them to do is to combine. So this is known as a combination reaction, also known as a synthesis reaction. All right, back to our second scenario. This time let's consider this copper sulfide. The copper forms 1 positive cations. The sulfide is still going to be 2 negative. And if you crisscross these numbers, you get a different ratio. You get 2 copper cations for every sulfide anion. This equation is not balanced. So to balance it, we need a coefficient of 2 in front of where we see copper on the reactants, because there's 2 of them on the products. So this compound is known as copper 1 sulfide. And if you're using the older naming convention, you use the Latin base with the OUS ending for the lower charge. So it's cuprous sulfide. Again, this is not very commonly used these days. One last thing, this combination reaction between copper in the presence of sulfur is oftentimes heated. Now, it didn't mention that in this problem, but if we did, you can denote that with this delta symbol. Or you could write the word heat over the arrow. And that means heat is supplied to this reaction.